Hello, friends, and welcome to our Facebook Live today. This one is going to be so much fun because I love when we have engineers on our Facebook. It's so much fun. So today we have Kim Burton with us, and she is an engineer from Textron Aviation. Kim, I would love for you to tell everybody what kind of engineer you are and what you do.
Oh, thanks, Caitlin. Well, first, let me say thanks for letting me do this today. Kansas, the Discovery Center is one of my favorite places in the world. So maybe we do a live show from there next year. It'd be awesome, right?
Well, that would be awesome. Yes.
Cool. But this is fun, too. So I originally studied electrical engineering at Pittsburgh State University in Pittsburgh, Kansas. If anybody's watching from Southeast Kansas, I'll say hi. And I got into that because I just really loved, I loved physics in high school, wasn't really sure. And I also loved writing and, kind of had to just pick a direction eventually. So I went with electrical. It seemed like a really broad topic, somewhere where I could go a lot of places and do a lot of different things. And that's what happened. After my degree, I went into avionics engineering at Cessna Aircraft. Avionics is, it means aviation electronics. So we would figure out how to make anything needed to navigate, communicate in the airplane. Anything that you see in an instrument panel, that's avionics. All the antennas on the airplane, the radios that you need, that's avionics. Did that, and now I'm in customer service engineering. So we just answer questions about airplanes all day from all different kinds of systems, engines, the anti-ice, the landing gear. So it's been a journey. You just never know what you're going to go into in life. But I've gone around and I've had fun everywhere I am. People that I work with love airplanes, really passionate about it. So I've got the bug too.
I love that so much. And it's funny hearing from other engineers about their path and how they got there, because I have an industrial engineering degree and I knew at 10 years old I wanted to be an engineer because of the game Roller Coaster Tycoon. So it's you never know what's going to spark you and really make you like take the path you want to be. So engineering is so much fun. And avionics. Now, I know when people think about like airplanes and aerospace engineering, they just pretty much think that engineers work on the wings and lift and things like that. And so it's fun to hear that there's something specific to the panel. So how many different types of engineers do you work with? Because you said you were specific to the panel and things like that. So could you talk about the different types of engineers that you work with?
Oh, there's so many. And when you are designing a new airplane, it takes hundreds of people, engineers, to do that. And we work together, but I'll work with my little group of electrical engineers and stuff like that. And then there will be a whole separate group of people who are thinking about the wings and aerodynamics and the flight controls. A group of people usually focused on the landing gear, the hydraulic systems, how those work. If you look at their degrees, they're probably a mix of mechanical, aerospace. We'll have some math majors. It takes all types, really. I can't even probably name them all. Propulsion engineers, a lot of them will have mechanical or aerospace degrees, and they'll just think about the engines. And then we all come together to make it all work together, and it's amazing.
That is so cool. So an airplane, there's so many different things on an airplane that you have to think about. Like you just said, it takes so many different types of training and different engineers and maybe not even engineers. You said math majors as well. So tons of different kinds of brainwaves going on there. It sounds like there's a lot of problems to solve. So could you talk about how all those types of career paths all have that common thread of problem solving? Because even in our job here at the Discovery Center, there's always problems to solve. So in every job, there's problems. So could you talk about the importance of problem solving and maybe how your degree, your training helped you in that?
It's almost two different kinds of categories, because when we're designing an airplane, we're really thinking about the constraints. We only have Textron Aviation we have two brands in production. We have the Cessna airplanes and Beechcraft airplanes. But across all of the lines we seat, 4 people to like 10 or 12 is like the biggest airplane we make. So these are small, and we're trying to fit a ton of stuff in there. Weight is critical. We're constantly trying to save weight. Space is at a premium. And so as an electrical engineer, I want to put a box anywhere I darn well please. But we've got, we'd model this all up in computers, and we get in a room and we have these big meetings where we just look at, okay, what is the best place to put this? Who else needs to put something there? Is there room? How are we going to access it? Because we've got a whole discipline, a whole group of people who just think about how are you going to maintain that airplane? If you ever have to take the box out and replace it, is it going to be easy to get to? We have a million little things to think about, and we think about it as a team. So that's really the problem solving that we do, is getting together and just brainstorming and hashing out how it's all going to work. And then after it's out, and really what I do now is I work in our service center. We've got 5 airplane hangars in one. We got 5 airplane hangars in one building on the west side of Wichita. And it's all people maintaining and upgrading and sometimes troubleshooting airplanes. And we become like professional problem solvers at that point. Troubleshooting is a beautiful thing. You think that as an engineer, you'd have something and you make it and it's great, but sometimes you'll hear some feedback. Somebody will just say, well, this display is doing something weird. Well, what's it doing? Oh, well, the oil pressure went invalid for like a second. Okay, well, now we've got a problem statement. If you think about your old scientific method when you were in the 3rd grade, what's the first step? You got to state the problem. And so then we think about, okay, well, where's that signal coming from? And what's the sensor? And where do we get to it? And has there been any other, what could have caused that? And it's so cool. You have to divide up a system into little parts. The best way to find out why something's not working is to find all the little places that are working. And so you develop a test. And that's part of the scientific method too. Develop a little test. How can we make sure that the sensor is working and that the wires from the sensor to the display are working and the display itself is working and all that little stuff, dividing it up. And that's how we can figure out why it did that one time.
That is awesome. And I love when engineers start talking about troubleshooting and problem solving and things like that, because what we may not hear a lot is the word failure and how important failing is to the whole process. Because if it doesn't fail during your test, how are you going to make sure you have everything worked out? So could you talk about the importance of failure in your job?
Let me think. It's interesting because in aviation, you go through any little part that's on an airplane goes through so many little tiny incremental steps before it's actually on an airplane. And yeah, we do. We try to make parts fail. We try to bend things and individual little components and just see what their points are. When we install a box in an airplane, let's say it's a little computer. It will come with records of all the tests that sometimes we have even helped do because we document everything. And so it'll say this box is certified to work up to 200 degrees Fahrenheit or something like that. And so then we'll do another test on our airplane to see, well, how hot does that little region go? And we'll make sure that even if it's out in the sun for hours and soaking and stuff like that, well, how hot does the world have to be for that part of the airplane to get up to 200 degrees Fahrenheit? We put all of that together, all those limitations to tell people, what the regions can be and how hot it can be and when you need to kind of pre-cool stuff down or something like that. And try to make it so it'll just work all over the world.
Yeah, that is so cool. Well, if anybody watching has any questions or comments or anything, go ahead and put that in the comment section below and we'll see if we can get it answered. But Kim, I do have a question for you that's pretty basic, if you don't mind answering. How do planes actually fly?
Well, yeah, no, that's a really great question. So when air moves over the wings, there's this principle you might have learned, Bernoulli's principle. When a fluid moves rapidly, and air is kind of like a big fluid, it creates a pressure differential. And so actually the best way we have to show this is with a silly little piece of paper. And I got one here. So I'm going to blow on this piece of paper and see what happens to it. See how it kind of went up? So the way airplanes
Yeah.
fly is air kind of sucks the wings up into the air when it makes a a vacuum up there, and you can change the angle of the wing to provide more of that lift. So when you see an airplane pointed up, it doesn't climb just because the engines are providing thrust, downward. It climbs because the wings are providing more upward lift.
That is so cool. We have at the Discovery Center the Bernoulli table where you can balance the ping pong balls on the flow of air coming out. And so that's the same principle that you're talking about there. So when we're at the Discovery Center and you have the ping pong balls just kind of floating on the air there, you're actually doing similar tests to what Kim might do at at Textron or something like that. And so those are the foundations that we're trying to create at the Discovery Center, is those learning principles. So that's so cool. Now we've talked about flying. I've always been curious. I would expect to see more wheels on an airplane for landing. So why do airplanes have so few wheels? Are more not needed?
Oh, the three wheels. We've got like the nose and then the two on the side by the wings. Yeah. Yeah, well,
Yeah.
hey, that's all we need. I talked earlier about how weight was so important. Now, I'm glad that your car has four wheels, because your car, you need to turn corners really fast, and maybe it's rainy and icing out and you're trying to make a quick left turn, and you need that extra stability so that it can go. Airplanes don't need to taxi at 60 miles an hour. In fact, when I was learning how to taxi my little single engine, they told me that I could taxi as fast as people were walking and not much faster. So they're made for flying, and to go straight down a runway, you only need three wheels. Your three-legged stool will stay up that just right. And just the way that an airplane is kind of balanced. We've got that nose gear can just be in the center to hold it up in one direction, and then the two, we call those the mains, on either side to keep it from going left and right. That is enough. Older airplanes used to have that single gear in the back. It was called a conventional. Sometimes we call them tail draggers. So that works too. It's great. We think that the tricycle configuration is a little bit easier to land. You get the mains down and then the nose can go from there. Yeah, good question.
Very cool. That's awesome. Now, I know you talked about the panels and getting to do that. Have you ever gotten to fly a plane before?
Yeah, actually, I have a private pilot's license too that I got while I was working at Cessna. The company, they like a lot of pilots, in our population. A lot of people were so passionate about it, and so we have an employee flying club at Textron Aviation. So we get a pretty good deal on flying lessons, and so a private pilot's license means that I can fly my own friends and family around in nice weather, and I can fly a single engine land airplane. And then there's a million different endorsements and updates from that and stuff like that. So I don't have a commercial pilot's license. I'm not allowed to have anybody pay me to fly. I don't have an instrument rating. That's what you would get if you wanted to fly like through clouds where you can't see anymore and you have to only rely on your instruments to stay right side up. Or a complex endorsement that I would need to fly something with a retractable landing gear. But private pilot's license, I've flown to Topeka. I've landed at your airport. It's really fun. It's about from Wichita, Kansas, where I'm at, about a 45 minutes to get me to Topeka in a Cessna 172. It was great.
Nice. That's so cool. A little faster than driving too. That's awesome. So many fun things you get to do. Now, I know that when you think of engineering, you often think, you fix things, you do lots of different things. Since you work on electronics and the panels, I was curious, do you code very often?
I've written some codes and scripts just to kind of help me out in like Microsoft Excel macros and kind of stuff. And so sometimes we need a tool, it's kind of like, sometimes you use a calculator to speed up your calculations. Sometimes it's just easier to write a script that'll do something real fast for you. But no, I'm not a software engineer. There are software engineers, as part of, and obviously there's a lot of stuff behind those displays that we use now. There's a lot of coding and software so that's one group of people for sure doing some codes. But for me as an average day, no, it's just we are documenting, we are testing, we are putting our designs on paper. Most of the time that I spent as a designer was breaking up, drawing the schematics for each box and what information it would need. Your transponder now needs to have GPS information. So it needs to be wired to the GPS, and then everything needs to be wired to power, and then everything needs, something needs its own antenna. And so we had stacks and stacks of drawings defining how each part of the airplane was going to be wired. Because after we find out what everybody needs, then we would say, well, this goes in the, here's what everything's in the nose, and here's the wire bundle for the nose. Here's everything that's in the tail, wire bundle for the tail. Helps to be very, very organized. And then we would write big reports about those things and documentation and help guides and train people about them. And that's how we spent our time.
Okay, very cool. So the different engineers that you talked about earlier have those different, basically maybe expertise, and you bring that all together. We have a couple of questions coming through. One from Don Burton, you might know them. What is the most essential skill to bring to teamwork, since they have all those, the different kinds of expertise and things? So the essential skills that everybody brings. And then you talked about writing. Do engineers need writing skills?
Oh, yeah, great question, Dawn. Thank you. Yeah, engineers, it's huge. So when I was a kid in school, sometimes I would get a point taken off of my math because I didn't show my work enough. And I would think, man, it's so great when someday I'll be out of school and I won't have to show my work. Well, that's not how the world works. You have to show your work even more, because even though you're an engineer and you have a degree, you can't just tell to somebody, yeah, this airplane's totally safe. I took differential equations, so obviously I'm smart enough. You have to trust me. Trust me is not a means of compliance. Writing down all the tests that you have done and bringing a whole lot of people with you before you can even send it to the FAA or any of the industry standard stuff like that. You have to convince everybody on your team, supervisors, very, very experienced people who want to know how you arrived at those conclusions. And that is writing. So the essential skills are not only writing, but organization, being able to keep track and being able to work with people and work in a team and have everybody share in your journey of how you got to a certain idea. That's how they'll agree with you, and how everybody can realize that what you're doing is right.
That's awesome. And then we had another question that comes in that talks, a little bit about the schooling and things like that. We had a question. What is one of the things you wish to know before jumping into training, schooling, and now working as a professional engineer?
Yeah, that's another good question. The education teaches you so much about how to think, and it's a great place where you can really prove your dedication to the field. You learn how to jump into a project. But I've had to learn so much as someone in the workforce. I mean, when I came to work, the software that we were using to draw those schematics was not something that I had learned in school, and that was okay. I was able to learn that on my feet. And I honestly, my degree was pure electrical. I had not learned very much about even aviation or avionics. I learned that just from being in the workforce and on the fly. And so really the lesson that I've taken back is you should always be open to learning new things and thinking on your feet. When I talk to college students, I love hearing about their projects. And especially, in college, you'll do a capstone project, senior projects and stuff like that. Those are so critical because it proves that you can do something on your own. That's not just a worksheet that the teacher handed you and you get, the answer at the end of the week and it's 6 and you turn it in and they tell you whether or not it was 6 or 7 or something like that. What we have to do all the time is look at big, vague situations that are not laid out like an IKEA table with instructions and figure out a first step. So the essential skills are initiative and willingness to try something and trying to jump in when other people just kind of want a blank stare at a problem.
Absolutely. I remember my capstone program. We had to design a whole almost business and like design parts and sell them and everything. And I remember feeling so grown up during that class because it was like the teacher just stood back and said, you guys got to figure it out. And we had to figure out, you know, the business behind it as well as the engineering portion of it. And I think that was a really big eye-opening skill where the teamwork came into play because it took so many different things just to push one product out. And so I really appreciate my training as an engineer just on a general level of the teamwork and things like that. So it's so much fun to hear different backgrounds of engineers and that kind of thing. So that's so cool. Thanks for sharing about that.
I think I've heard a lot of students or people thinking about going into engineering, but they're concerned that they haven't done enough in their past. And I always try to tell them like, it's going to be okay. Cause they're like, well, I want to be an engineer, but I haven't, you know, reprogrammed all my kitchen devices or built a car from scratch or all these things. And that's okay. As long as you've done something, I don't care if it's party planning. If you have taken an idea and brought it all the way to fruition and you have proven that you can jump in, that's okay. We'll teach you a lot more about what you need to know.
Exactly. It's the will to not give up on a problem, I think is what I see a lot in engineers. Because I know when problems arise, I get so excited that I want to try to figure it out. And I see that as a common thread in other engineers. They're just so excited to try to figure out the problem. So I think just wanting to solve the problem is, like you're saying, is a big part of it. And then you can teach specifics later. So that's so cool. About the specifics, you talked about the different types of planes that you work on. Could you talk a little bit more specifically? And did you have any pictures that maybe we could show people what the kind of planes you're working on looks like?
So yeah, let's see. I work on turboprops. And that's talking about the engine of the airplane. We've got 3 different types of engines that we put on airplanes at Textron Aviation. Pistons, which is an engine kind of like what's in your car. Your car has a piston engine. And it uses those to turn, you know, instead of turning wheels, you're turning a propeller. And then jet engines, which everybody's real familiar with, where, you know, air comes in, it gets compressed and heated up in stages and provides thrust. A turboprop is almost like a jet engine turned around. And so we use the energy to spin a prop. So more powerful than pistons. It's awesome. But we don't have to have as big of an engine as a jet. And so it makes for a lighter weight airplane. Little bit shorter range, but we can land on shorter runways. It's more fuel efficient. A lot of benefits to turboprops. So the one that we've got most in the field right now is the King Air. The King Air is an airplane we have been making it for 55 years, and it's amazing. And everybody in the world has heard about it. Seats 6 to 12 people, depending on what you've, or 6 to 8 people, depending on what you've, which variety you have. And there's a ton of varieties. And then let's see here. So yeah, I've got an instrument panel picture, but the other one that we've got coming up that I know I sent you a picture. Oh yeah, there's King Air panel. I didn't know how much instrument panel stuff we were going to talk about. I could talk about instrument panels for a million years. Our latest, newest turboprop is the Sky Courier. And I've got a picture of that one too. That's going to be awesome. So this is a picture from Sunday. We just had first flight of the Sky Courier. There's been engineers been working on this for months, getting this together and tested. And it's going to be amazing. It's always fun whenever we crank out a brand new design. And so the reason this airplane is green, don't worry, it will not always be that color, but that's the primer color on the aluminum. We didn't need to paint it. This is going to be our test bed for a while. We may paint it eventually, but it didn't need for Sunday. We were just really excited to fly it. This is going to be our prototype. We're going to do a ton of testing, like we talked about, and evaluation, and it's going to be cool. So that's an example of types of airplanes that I've been working on.
That is so cool. Now, I know you mentioned color, like it won't stay that color, the primer's that color. When you're working the panels that you're seeing, are there specific colors or sizes of buttons and maybe safety measures that have to go into that? Like, do you have to use certain colors for a certain reason or shapes for a certain reason?
Oh yeah. Yeah, I guess now we can go back to the panel. I mean, some of this aesthetics, you know, so when I talked about the green exterior airplane or something like that. We mostly paint airplanes white, sometimes gray. There's some different paint jobs and stuff like that. People don't go too crazy with them. But in the instrument panel, suddenly colors mean something. So for example, we only use red for a warning that has to get your attention, that has to say, hey, there's flight crew, there is something that you need to know to keep flying this airplane safely. We use yellow or amber for caution, and other colors for everything else, for notifications and that kind of thing. So I don't know what you can see on this one. For example, like the landing gear handle. I mean, every button means something, but there's like a little white handle in the kind of the middle, but it's over to the left. It's got a little red line on it. That means that your gear is in transit. So it's not up or down yet. So it's saying, hey, until it's down and locked, this button's going to be red. And that's your signal that you shouldn't land on it yet. And then when you see that go away and you get 3 green lights, green means go and good, then you're good to land. So colors are people got together as an industry and decided what these are going to mean. And so they are very standard. Any airplane you go in is going to use the same thing.
That is so cool. Now I see a ton of buttons on this picture that you have here. Are any of the buttons the same, like mirrored, or does it take 2 pilots to fly this one? Does that make sense?
Oh, yeah, good question. The King Air is certified for single pilot. So one person can fly this by himself. But there's also on the co-pilot has a lot of the same buttons. So for example, he also has an autopilot disconnect. He has a radio key will be on his little control wheel over there. So he or she can talk on the radios. Other airplanes, bigger airplanes, require 2 pilots to fly, but a lot of times they'll still have the same controls. There is actually a whole group of engineers. See, now you brought up another thing, another group of engineers. Human factors is like a mix of engineering and psychology. And they lay out, one of the things that they think about is how can we lay out all these buttons and a cockpit to be really usable so that people could, with some training, pilots obviously have to have a ton of training, and training is in each type of airplane that they fly. But we want it to be intuitive. We want things to be easy to find. We want there to be like a logical flow to how everything goes. And there's a whole science of that. That's a whole other discipline. We'll time people on how fast they can complete emergency procedures. It's really cool.
Oh, fascinating. So does that mean like for different size planes that take 1 or 2, if there's an emergency button, if you think about the psychology, is that typically in the same place in most airplanes, even if they're different types of airplanes?
Most airplanes have, so on the control yoke, most airplanes will have, I think the red button there is probably autopilot disconnect. I'm going to make it real easy to disconnect an autopilot just in case. I mean, it's like a computer that's flying your airplane. If it's doing something that you don't want it to do, you disconnect it really fast. So that's a really common button. And then the other, communications, there'll be something to set the comm radio to the emergency frequency really fast, those kinds of buttons. And so, sometimes we'll put those in the same place. Trying to think of, what other things you would have to use in an emergency. Pilots mostly get trained. I mean, they train so much on what the different emergencies are. If there's a red message also, that means that there is a procedure in the pilot book that they have to memorize. So something like there's an engine fire or, anything else that might go wrong, low oil pressure or something that's a big deal. They have to know instantly what to do it, and they train for that in any airplane that they are in.
Okay. That's really cool. Now, while you're flying, I know there's, Gforce and things like that. So could you talk a little bit of what it's like up in the air with the Gforce and how that feels on the body?
I've only flown a Cessna 172. Now I have flown in a King Air, and many of our airplanes and stuff like that. We don't put a whole lot of G-forces on our airplanes. We are not stunt pilots. So the most, I don't even know how many, maybe 2 or 3 that I've experienced while just doing like steep turns. In 172, you practice turning at like a 30-degree bank. Not really that big of a deal for me, but man, if you ever guys do ask a fighter pilot, you'll have to talk to them about that because they have to train how to like clench their whole body up to keep the blood in the right places and stuff like that. But Not for general aviation. We stay pretty calm.
Pretty calm. Okay, so Gforce, like we feel 1G, the weight on our body while we're on Earth, and so that's why I was asking if as you go faster and there's more pressure put on your bodies, your G's enforce and they can multiply. So it feels like 2G's like double your body weight and things like that on your body. So it's interesting because you think about the movies and what it looks like in the movies. Would that really happen in planes that we develop? So I don't know if there's any. I can't think of a movie, but like the warnings that happen in movies and things like that. If you watch a movie that's like an airplane based thing, are you looking for things that are wrong or things like that? Have you found any differences in like how they depict airplanes in movies?
Yeah, I do. It's kind of funny. I think the biggest things that I see in movies that crack me up is, well, again, about engineers and knowing things. There was a movie with Jodie Foster in it where she was in one airplane and she was like, "Oh, I've worked on airplanes before, so I'll know how to rewire this entire thing to do what I want instantly." And sadly, that's not how it works. We don't have like a certain color coded wire for the put your computer directly into the autopilot and make it do what you want. That's not even a function that can happen. So you're not going to be able to rewire, and all the wires are white. Well, in ours anyway. So unless you have a serious background, you built that airplane yourself, you're not going to know everything about it to re-engineer it in the air. I think that's, another kind of stereotype about engineers, that we're just sort of divinely inspired and we know everything instantly. It's funny.
It is. I remember being told several times, well, you're an engineer, you can figure it out. Or, hey, what kind of screw would I need for this? Because you're an engineer, you know those things. When we don't know all the hardware that's out there and all the different types of things that are out there. Like we talked earlier, we're here for problem solving and figuring it out. So it's really funny that you mentioned that. With that. And on the thought of stereotypes, I'd like to hear your thoughts on women and girls in engineering. Why do you think more women and girls don't go into engineering?
Oh, that's true. Because throughout most of my career, there's been maybe 20% or so of the people I've worked with are women. And there could totally be more. There's no reason why women shouldn't be going into engineering as a career more. I think maybe they just don't really know what engineers do. I mean, we all watch like doctor shows on TV. We know what teachers do because people teach us. And there were times when I was learning how to be an engineer where I felt like people would ask me like, "Oh, you're a woman going to this field. Why? What's your story? You must have some complicated like divine inspiration, big reason to be there." Whereas some of the men I would see men just kind of shrug me like, "Well, I'm not really sure what to be. I guess I'll be an engineer." And and everything was okay. It didn't seem like it was something that women would just casually pick. And even some women I knew who were really, really smart, who I thought would be great at the problem solving and explaining themselves and getting into it. Engineering needs so many people right now, and it needs so many people with different kinds of intelligences that we need to be recruiting more and encouraging more girls to go into it. So I hope the numbers continue to increase. I really do.
I agree. I remember sitting in a class in college. There's 200 people in my class, and I could tell you where the other two girls sat in the class. And that wasn't terribly long ago. So I love that we're able to do these kinds of things where we can bring a female engineer on and talk about what you do and how you solve problems and different things like that. So I appreciate you coming on and talking with us about this. Now, for our viewers out there, if you have any questions at all, go ahead and post them in the comments here. But I do have a couple other questions for you. As an engineer, what's one of your favorite experiments that you like to do?
Oh my gosh. Well, the environmental testing is pretty cool. We have a cold chamber that we freeze stuff. We bring it down to real low temperatures. And when you open the door, all of this like frost and condensate and steam and stuff like that, it comes out, and you immediately feel it. And I mean, it just feels unbelievably cold. We also have a chamber that's essentially, it's almost like a giant microwave, where we'll put the electronics in there. We'll put a whole setup in there, and watch it to see, okay, because the question we're trying to ask is what happens if an airplane is flying, next to like a really high powered antenna, or next to some radiated field, or or lightning is in the area or something like that. The electronics are, what happens if we jumble all that? It's cool to see. To do those tests, we have to basically set up the system on a table. So it's a lot of work, but we learn a lot from it and we prove out our designs. It's neat to see happen.
That is so cool. So you get to do a lot of different kinds of testing on the things you design, which we do a lot of that at the Discovery Center. We like to follow the engineering design process of, building, creating, planning, research, and then like we talked about, improving, testing and improving different things like that. So I'll go ahead. I have one more question for you, and then we can kind of wrap this up. What would you tell a young girl, boy, anybody who wants to go into engineering? What would you want to tell them about going into the engineering field? Any advice, suggestions for them?
I would just encourage them to stick with it. It's going to be hard, and there's going to be some classes that you feel like, that you're worried about. There are some difficult classes, but it's so worth it. Go into a general degree. You don't have to know exactly what you want. I know that there's some programs. I swear some colleges keep getting more and more specific on their programs to try to get people who are really excited about, like, I don't know, like acoustic sports engineering or something really, I don't know, just electrical, mechanical, aerospace. It's okay to stay totally general. You don't have to have everything laid out in front of you, and just go for it. Be absorbed in what you're doing. Try to learn what you're doing. Use what you're doing in school for your everyday life. If you've got a question about how to fix your house or your car or anything, YouTube it. There's so much great stuff now that we didn't have when we were kids, to just learn new skills and dive in. And it's a lot of fun. Like, you will be, I'm really happy that I chose engineering.
Me too. Even though I may not be in the traditional job of an engineer, I love that I get to problem solve every day and teach people about engineering. That's one of my favorite things. And even beyond engineering, because like you said earlier, so many jobs that it takes to work on an airplane. So even if you don't want to follow the engineering path, there's probably other jobs out there where you could still work with airplanes, even if, in a different capacity. So lots of different ways that you can go into it and still work with planes and things like that as well. So I have one last question, just because I'm curious, because you said you've been to the Discovery Center before. What is your favorite part of the Discovery Center?
Okay, well, you probably get this a lot, but the tubes where you get to have the scarves blow around through them and stuff, and set up all those little valves, that you get to shut off and change the airflow and change how it's going to be and and have your own little path. Super fun. I could play with it and watch scarves fly around for hours. So I keep it going. It's awesome.
That is awesome. I do love the scarves, and I love to go play whenever I get a chance with everybody at the scarves section as well. So, well, I appreciate you coming on, and I know our friends at the Topeka Zoo are doing a chat about their jobs over there as well. So we love talking about different jobs in the world, and especially with community partners like the Topeka Zoo. Kim, thank you so much for coming on to talk about engineering and what you do and airplanes and things like that. And if anybody out there has any other questions, go ahead and feel free to put them in the comments or send us a message, and we'll do our best to get them answered for you. So, Kim, thanks so much for being on today.
Thank you, Caitlin. This was a blast.
All right.